going to talk to you about buoyancy. Question: what is buoyancy and where do we see buoyancy in the everyday world? Goal: to understand buoyancy, we need to learn about density, displaced water, weight, and the force that pushes up on an object. This force is called the buoyant force. Questions: to understand buoyancy, we will look at these questions. Can you make something float by changing its shape? Is it easier to swim in salty water like the ocean or fresh water like in a lake? Why does a heavy ship float but small rocks sink? How does an ice cube float? How do submarines work? And how does a hot air balloon rise? What is buoyancy? Over 2,000 years ago, a man named Archimedes discovered buoyancy. Buoyancy is to find out why something floats or sinks. If you put an object in water, it will displace more or less water. If it displaces more, then it will float. If the weight of the water displaced is more than the weight of the object, then it will float as well. A heavy ship will displace lots of water so that it can float. Density. If you pack a lot of molecules together, it will become very dense, so it will sink in the water. A brick has a lot of molecules packed together, so it sinks, since it is very dense. Something with high density. This means the molecules are packed very close. Styrofoam is not very dense because it has many air pockets. If an object is more dense than water, it will sink in water. Salt water is more dense than fresh water. Ice. Ice is less dense than water because it has air trapped in it. This means ice will float in water. In the winter, the water will freeze on the surface of a lake. If the ice was more dense than water, the ice at the surface would sink to the bottom of the lake. More ice would form on the surface, and in the end, the lake would be completely frozen solid, killing all the fish. So the fish are lucky that ice is less dense than water. Container ships. Heavy container ships float because at the bottom there is air, and that makes it less dense. The ship displaces a lot of water, which makes the buoyant force quite strong. If a container falls off the container ship, it's a big hazard because the container floats, and a sailor could run right into one and crash. Hot air balloons. A hot air balloon is very complicated. Hot air balloons. A hot air balloon is very complicated. It has a platform where the people stand. It has a burner to heat up the air in the balloon. The controller pulls a string which is attached to the top of a valve. At the top there's a valve, and at the top to let some of the air out. How does a hot air balloon go up? The driver turns on the burners to heat up the air in the balloon, and the air pushes on the top to go up. Hot air is less dense than cold air, so the balloon rises. Hot air balloon 2. How does a hot air balloon go down? The controller of the balloon will pull a string attached to the top, and it will let a bit of the hot air out. How does a hot air balloon go sideways? The controller will find a high altitude where there is some wind, and the wind will push it either which way. Submarine. When the density is up, the submarine will go down. When the density is down, the submarine will go up. The crew will control the density. When the submarine goes up, the crew replaces the water in the ballast tank with air, and to go down, they replace the air with water, and the density will get bigger. The main part of a submarine is the ballast tank. This is the donut shape right here around is the ballast tank. The crew will live in there, and to go down, they will push down right here. They will push water in there, and it'll fill up, and then in this picture, that's where it's filled up and it's down. And then there's air vents down there, and it'll push out the air, you see that little sheet on your desk? Gabby? Yeah, there. Look over. That's your experiment sheet. So you're going to write down your predictions. There's 5 experiments, and you have to write down your predictions. Okay, the first experiment. Floating or sinking oranges. Take 2 oranges, 1 peeled, 1 unpeeled. The unpeeled one weighs more. Which one do you think will float, and why? Here are my 2 oranges. So I'll let you guys write down your predictions. The one with the peel weighs more than the one with the unpeeled.
Wait, the unpeeled one weighs
This one weighs more. Is everyone done writing? E-E-N-S-E. Is everyone done?
No.
Yeah. Is everyone done now?
Yeah.
Okay. Let's see. Okay, now I'm going to tell you the answer. Buoyancy is not all about weight, it's about density. The one with the peel has lower density since there's air trapped beneath the flesh and the skin.
Please excuse this interruption. We are starting our photos of our clubs. If the adult who sponsors the club can excuse themselves and come down.
Suppose an object sinks. Can you take the same object and change its shape so now it will float? What should you try and do? Hint, think of this. Water. I'll put that up and everybody else listen to Nolan. Yeah, oh yeah. Don't write you guys can write down your predictions. So this is the ball of silly putty. When I put it in the ball, it will obviously sink. But what other shape do you think I could change it into? Max?
Like, maybe a square or like a flat object, like just flat.
Okay. Almost. One more. Emma.
You can make it into the shape of a boat.
Okay, let's try that. there is air trapped in the top. Okay. Experiment number 3. When you make a bunch of metal coins float in water. Hint, think of a container ship. So, coins obviously sink on their own. But what other things could I use to get them to float? Max.
A container?
Okay, let's try that. I have a little container right here. Okay. You are right. Does anyone know why this floats? Nina.
Because air is trapped
Yes.
inside the box.
And it makes it less dense.
In a garbage can.
Is it easier to swim in an ocean or a lake? You have to write it down. This is going to be the ocean. And this is going to be a lake.
Are you going to put salt in the lake? Or the ocean?
Yes, I will. If you're thinking that's a lot of salt, think how much there is in the ocean. Okay, this is my example. Yeah. He will sink in the lake,
Ocean.
but let's try if he sinks in an ocean. He floats. Does anyone know why he floats? Gino.
Because in the salt there's, I guess, a bit of air trap, and even when you're in salt water, it'll be easier to swim because you're more buoyant because of the salt. If you took out
Not exactly. Max?
The salt makes it the salt makes the water more dense, so it's easier for stuff to sort of almost
Yeah.
concrete's very dense, so it's easy to stand on it or to lie down.
The salt gets dissolved and it kind of is pushing up on the water, so it's like the whole ocean is like a big raft, and you could just lay on it. And it's not the strongest raft, but it's most likely to hold you up. Now for the last and probably best experiment. Experiment number 5. Do raisins float in water? Can we get raisins to dance by changing the water to some other liquid? Okay, so raisins float on their own, sink on their own. But how can we get them to go up and down? Nina?
No. Wait, I was gonna say salt water, but
Evan.
like soda.
Let's see.
Oh my god.
something good in the experiment. Okay, now let's see what will happen.
Soda has been raising some soda and see if they'll go up and down for dancing.
Does anyone know why this is happening? Briefly.
Because the bubbles are pushing it up.
Nope. No. Max?
Because there's air bubbles in the soda.
There's air bubbles in the bubbles, and they get attached to the raisin, and they'll bring it up, and at the surface, they'll pop, and then the raisin will sink back down. And that's my presentation. Look down, can you see?
Please excuse this interruption. We are now calling.
Everyone, I understand it, but I still don't really understand how air can like hold a solid object up, sort of like there's air in the container, and it sort of is holding up the coins.
Because it,
An answer to your question, Max, is because air is lighter than an object. And
Yeah.
lighter stuff goes up.